Hello everyone and welcome to the e-workshop Talk Third, which is organized by GeoVigyan. Hope you are all fine. And before starting session, you can ask your queries in YouTube chat like live box, from where we will take your questions directly to the presenter. So today we have with us Mr. Abiola Sylvester Akinnubi. I want to introduce him that he has a wealth of experience that has covered couple of industries with previous work history as a geophysicist, data mining engineer, and software engineer, whose expertise spans across multiple industries. This has enabled him to work across a broad spectrum of projects. Abiola has a first degree in applied geology and a master in exploration geophysics from Federal University of Technology, Akure. With these qualifications and expertise, he worked as a data engineer, a geophysicist, and a software engineer in the following industries: energy, insurance, FinTech, tech consulting, technology teaching, to list a few. Some of the organizations he worked full time with are Abyss, Data, Leadway Assurance, and Salutant. A data engineer, he was also a consultant for Entrica on a crucial project to deliver innovative ideas for geophysical information mining. He also consulted for Maple Leaf Technology as an engineering manager. Abiola has also mentored and inspired several brilliant individuals who now work in world-class organizations. He is currently pursuing his PhD in Computer and Information Science at the University of Arkansas, Little Rock. Here he will be mentored and work closely with Dr. Nidhi Agrawal, who is Distinguished Professor of Information Sciences. He is currently researching and working on misinformation online through social behavior studies by applying machine learning and graph theory, among other advanced computational principles, and will spend some years doing so. His focus is on applying software engineering and machine learning principle in problem solving. Now, he also leads a team working on block tracker project to mine deep site and analytical using behavior studies. And today he is with us to deliver a talk on the topic of data analytics and machine learning in geosciences. Thank you. Over to you, sir.
Okay, thank you, everyone. Good evening, good morning, good day, wherever you're watching from. Thank you for the introduction, and I would proceed with sharing, with starting the presentation, and then we'll take it from there. Okay, so basically, this is a workshop, and like you all know, it is to serve as a precursor towards how we would all be able to go into our individual shell much later at the end of the workshop to apply some of this knowledge, or to inquire more, or to dive deeper and make good use of some of the information we'll be able to gather from this workshop, and apply it accordingly in our individual endeavors. So basically, if you can look at if you see what I'm sharing, I mean, you can see I have like an image of a petrophysical well log on the side. I have an image of a seismic horizon at the bottom, and all that. And you might wonder that you've been using softwares like Petrel and the likes, and I mean, these are proprietary software, and how do you apply what you will learn today, and I mean, be able to produce some of this type of output? Essentially, this is possible with the recent advent of machine learning, data science, data analytics, and programming language like Python. And with that, you are able to build something like this for yourself, or create something like this, some of this workflow, which essentially reduces how much of leverage you have on softwares like Petre, Interactive Petrophysics, IPlog, and the likes. This is essentially not to take away some of those software, but to say that some of our basic workflow, or some of the workflow that we do on a daily basis, can actually be automated by us using geophysical, using Python and some of the tools that are available to solve geophysical problem. So, so the first question is, why should I care? I mean, for somebody that has been practicing, some of you may have been practicing as a geophysicist over the year, or geologist, geochemist, and the likes. And you might be wondering, why should I care? I mean, what's there for me? And essentially, you would see that some of these tools, some of the analytics that you do in geochemistry, in 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 petrophysics, in geophysics, in geology, and the likes, you can actually build a small basic stuff that automate some of these things, or that carry out some of these tasks, that perform some of these tasks. And with that, I mean, you would be able to build your own tooling. So one of the reasons you should care is the fact that you would have the ability to be able to build your own tooling. That means that having interest in machine learning and data science as applied to geoscience means that you'll be able to build your own tooling and have that form of capability of your own. Also, you have the ability to manipulate data. When you load your data into TechLog, interactive petrophysics, petrel, and the likes, you don't really know what is going on behind the hood. But a lot of data manipulation is going on behind the hood in terms of storing data, moving data back and forth, knowing what you're doing when you're picking your seismic horizon cube and all that. And with this capability, with knowledge in this area, you'll be able to manipulate your own data. Also, one of the things you'll be able to do is the ability to be able to extract more insight and augment field data set. Essentially, what this means is that if you have, say, you carry out a geochemical study on a certain geologic formation, and after carrying out the geochemical study, you find that there are certain kerogen types, there are several plot types that you can do in geochemistry that tells you if the hydrocarbon is present there or not. Some of those data augmentation and also manipulating your field data set and making it bring out the right insight, you can actually carry it out using some of this programming knowledge that borders around machine learning and data science. So, are there use case? That's a good question. Okay, so essentially there are use case because there are use case in geochemistry or geochemical analysis. There are use case in petrophysical evaluation where you generate petrophysical well log and also carry out cross plots. Some of us that may be familiar with um, all the cross plot that we have in petrophysics that we use in predicting fluid and the likes, you'll be able to carry that out with knowledge in data science and machine learning, and also enabling yourself with Python skill set under a tool belt. So also you'll be able to visualize seismic data. There are Python tools these days in open source that allow us visualize binary data like seismic data. We are able to see seismic headers. We're able to see each of the seismic lines and all that, and also visualize and manipulate it within our laptop or machine. Also, we'll be able to carry out data prediction using image recognition and likes. I've been able to apply some of this knowledge in some of these areas that I've listed here. I mean, from being able to predict geophysical well log when mining information from several remote resources or from several computer sets and aggregating them into a central archive and all that. You use a lot of image recognition and text prediction or I can hear you. Okay, how about now? Okay, so essentially, some of these tools that you need to master are Python. Python is a programming language which you'll be able to use to do a whole lot of stuff. And there are several libraries that are built around this Python. Example is Pandas. Pandas is a data frame, or think of it like how you're able to store your information in tables and all that. So you use Pandas a lot for all this manipulating information into tables and the likes. Then Matplotlib. Matplotlib is a charting library. Essentially, a lot of implementation of Matplotlib as applied to geoscience involves plotting well logs and generating crossplot and the likes. Also, one of the tools that you may need to use in terms of writing Python program on your laptop or online anywhere is called Jupyter Notebook. Jupyter Notebooks allow you to have that collection where you can aggregate all your code or the stuff that you've typed into it. And also NumPy is used for like your matrix. Some of us that have geoscience background, we are very familiar with matrix and like, so it allows you to essentially generate like an array or matrix, as they will call it in geoscience. Then another library is the Tesseract. Tesseract allows you to carry out text recognition. So let's say, for instance, you're trying to generate a data mining around information based on their content. Tesseract is like an OCR library that allows you to extract text from an image and be able to find one or two stuff from it. Another tool is the VS Code for writing your code. Then we also have tools like MinPy that is used especially in time series and all those stuff. Then we have Apache Spark. Apache Spark is essentially applicable when you start having large data sets and you want to be able to manipulate large data sets because it gives you a lot of capability in terms of streaming and likes. Then we have TensorFlow. TensorFlow is used a lot in areas of machine learning as applied to various further. And then some of the online platform that you can make good use of, especially when you don't have a large machine, is Databricks. Databricks allows you to perform some computational resources on their own server, giving you a typical machine to be able to use online. So you're able to set up and write some Python script online, Spark and all that. Then another tool that you can download on your laptop is called Anaconda. Anaconda comes with a collection of a whole lot of Python library that you may need on a daily basis. And it is just like a collection or a toolbox. Sorry. Okay, so example of a typical workflow in geoscience, a typical workflow machine learning or data science workflow in geoscience involves you importing your data or reading your data from the data source, you being able to process your data, you being able to visualize or reevaluate the first import that of the data set you process. Then from there, you are able to model the data, and then you are also able to evaluate the data. So, for us, because I understand that some of us may not have some certain background, and that is why I would say some part of today's class would border around things like discussing how to get started with Python for geoscientists. What are some of the Python data types? What are control flows and operators? Python's objects and collection. How do you handle exception or errors? And then much later we'll deal with file. So from the dealing with file is where we'll be able to implement some of the maybe a basic example workflow in Python that a typical geoscientist would use on a daily basis. So essentially with this, I am about to say, do I really need to know all that? I mean, that's scary. Oh, do I need to know all that? Actually, you don't need to know that at a go. You start with a subset and build up a knowledge. For instance, the key thing you need to start with is, say something like Python. And then when you start with Python, you move into using pandas. And when you know how to use pandas, you try to use matplotlib for some cross-plotting. When you know how to do some cross-plotting using matplotlib, you are able to also um, um, do a whole lot of data visualization and the likes from all that. So essentially, it's a progressive learning. It's not, you don't need to ramp all that into your memory and trying to master it all. You start bit by bit, as project demand, as your interest demand, and then you before you know it, you have all this knowledge under your tool belt. So essentially, I would start um, in. I would like to start taking us through some stuffs in Python, but before I do that, as part of today's workshop, I like to know if there are questions so far. I mean, so that I can.
Hello, sir.
Yeah, are there questions? I like to, if there are questions, I like to take it before moving into showing them some stuff on Python and all that.
No, sir. There is no question till now. Your voice is interrupting, sir, in between.
Okay,
Now it's
okay,
Sir, you
okay.
can do one thing. You can close your camera.
okay.
Yes.
Okay, so how about now? Is my voice better now?
Yes, sir.
Okay. So essentially, we talked about Python. Um, what I'm using here is called VS Code, and Visual Studio Code, or VS Code as we popularly call it, allows you to write um, Python code in. It allows you to write Python code within your laptop, and essentially that is possible because I have something installed on my laptop that is called Anaconda. So um, I just download Anaconda on my laptop and I install it. I walk us through. I'll send us. I'll send us a link on how to. I'll send us a link on how to install Anaconda on our various machine. Although there are several online tools that you can use now, like Google Colab, like Azure Notebook, and the like. So if you recollect, essentially, I said we're going to talk about some Python data type, because if we don't know that, there's no way we'll be able to apply some of the skill set or some of the things that we'll do in further part of the the workshop. So that is why I am going to first start with us with Python, because I understand that some of us don't have that basic background. So I don't want to just go straight and start um, maybe doing an example Geophysical stuff, and then some of us are like, wow, how did you do that and all that. So in order not to leave us confused, I would start with what are some Python data types. So Python essentially is a scripting language, and it is dynamic in nature, but you don't need to bother yourself about that. So we'll just look at some basic data types that you need to know as a geoscientist. I'm not going to go in depth into a whole lot of advanced stuff for us not to get confused. So, for example, as a geophysicist, we deal with numbers. So, and or geoscientists, we deal with numbers. So, example, we can say, let's say weight, and we can set weight to um, none. So none in data type in Python means in what you know in other language as null. So it basically just means null, or some would say nothing. So this is essentially for us to handle things where there are no value or where there are missing values. We can also say weight underscore new to be equals to 2. So this is specifically a number, or some will call it an integer, but I think Python word they call it more of number. So these are examples of data type. And another one that is key that we also use a lot is, let me just say another one, with new underscore new. We can say 2.0. So these are examples of, say, some will call it floating point, floating point numbers. And we also have examples that are like, how do I put it, string. So strings are like your name. Let's just say my name. So this is like, maybe you are trying to write a well log location or something like that. So so these are some of the key data types that you will encounter on a day-to-day basis when you're working with Python as a geoscientist. So let's just see some of the stuff that, let's just print out some of them. Let's run. So you can see saying the type is none for the first one. Then let's see the second one. Let's see the type for that. That is int. Let's see the next one, float. Then let's see the next one, string. STR means string. So basically, we've just looked at like some of the 4 key data types that you encounter on a daily basis when you're working with the physical application. So for example, you might be wondering, like, oh, is there an example of how this is
Excuse me,
applicable?
sir.
Hello.
Excuse me, sir. I would like to interrupt you.
Okay.
Sir, actually, the participants are saying that the font size is very small, so they cannot see it. Could you increase the font size?
Okay. Okay, let me go and increase my font size. Where is it? So I'm trying to show us a last file now. I'm trying to show us a last file now. I just want to get one off my laptop and then show us so that we can see example of some of these data type. Just give me a moment. Just okay. Let me just just a moment. I'm about getting us a simple last file. So I want to show us example of some of these data type. Just some example. Okay, so for some of us, for us to see where applicable this is, let me increase. So this is an example of a petrophysical LAS file. And if you can see clearly, you can see some of the data type that we specified there. You can see this is a float. This will be treated as a string. This part will be treated as a string. This name of the company or the county will be treated as a string. The different log type that were run and all that. Then you can see that all this data that you can see here, they are example of a float or a type float. So this is to show you that when you start reading some of these files using Python, you would be able to read it and detect the data type, and from the data type know how to perform several other manipulation on this. So so another thing that I like to discuss on is the concept of and that's that I like to discuss about is the concept of operators and control flow. Mind you, what I discuss about data type is not 100% exhaustive, but I just want to be able to bring us up to speed, so that by the time we'll get into the other aspect of the workshop where we'll start demonstrating an example of a typical geophysical workflow, we will not be confused. So that's why I touch some of the like four crucial ones that I know that you will encounter the most as a geoscientist. So examples of operators and control flow. So in operators, there are several operators, and the one that you probably use the most is the assignment operator or equals operator. We call it assignment operator or equals to. So example of it is what we've done when we said weight. Example of it is when we said weight is equals to when we said weight is equals to say 2.0 or 3.0. So this is an assignment operator. But we have comparison operator. We can compare two things. So comparison operator is basically just using that equal to multiple times. So it's basically using equals to twice. So for example, I can say with new equals 3.0. So I'm comparing here now. I'm comparing. If I run this specifically, because they are the same thing, when I compare them, it's saying it is true. So this is also another form of data type, Boolean. I mean, I think I should also add it here, but I mean, but most of the time, the output of your comparison operator gives you either a true or false value. For instance, if I change this one to 34 and I run it, it will say false, because with new, I've set it to be 3.0 here, and then when I'm comparing it here, I'm comparing it with 34.0. So you will need it when you start comparing different, for instance, when you're trying to do your cutoff for your petrophysical well log, say maybe your gamma ray value, you want it to start from certain, so you can say wherever it is greater than or wherever it is equal to so value, and then you can be able to carry out that comparison. Another thing that you can use is also the greater than symbol or operator. Greater than, so we can say with new is greater than 34.0. If we run that, it is false because with new is less than it. But if we change it to, so greater than symbol is the Uh,
Hello, sir.
Hello, sir.
Can someone signify if you can hear me? Sorry.
Hello, sir.
Yeah, my audio was off.
Sir, we were not able to hear you since 10 minutes.
Oh, 10 minutes ago. Okay.
Yeah,
Sorry.
yeah.
So I will run through that again. Sorry. Okay. So basically, let's
Could
look
you
at.
please could you please tell us again? Like participants are requesting for the same. Like,
Okay. So
yeah.
for the participants, apologies. I think my mic went off. I didn't observe that. I was deeply I was so deep into the teaching that I didn't even notice that. So my sincere apology to all the participants. For instance, let me run through some parts that I've discussed before. I mean, that will give us a clue. So for instance, I'm performing a control flow here, and I said if weight new_new is less than 70, I want to say it is a sandstone lithology. You'll be encountering this a lot in when you're trying to determine what lithology type a typical well log is. And I showed an example of a typical last file that we use to produce an example of a well log. If some of you can recollect, you have several lithologies based on petrophysics, and you're able to predict that from these values that you have here, So these values are essentially used to predict lithology. So I'm just saying this is an example of how your typical petrel or some of this software are able to determine your lithology. And I said control flows allows you to tweak your geophysical data solution to behave in certain way or the other. So example, or essentially what I'm trying to say is that you can say if the value is met so criteria or XYZ criteria, it should behave like this, or if it meets another criteria, it should behave the other way around. So for instance, I said if GR is greater than 70, it should print shady sandstone. If GR equals close to 50, it should say it is an intercalation, and else you should say it is a shade. So that is just like an overview of what a control flow is. I am assuming that that is where some of you miss out on my audio. But to run on this one too, I talked about the assignment operator. I said the assignment operator example is equal to where you assign a value to a variable. Essentially, width new is a variable, like they will call it in programming. It means a variable. And I also talked about comparison. I said basically you are using two equals to symbol. You are comparing X and Y together. You are comparing if X and Y are the same thing. And I also looked at the greater than symbol, which is also used as a comparison tool as well. You can say if one is greater than 2, it should say this and that, or should perform X, Y, Z. And we also looked at the less than symbol, which is also another part of the comparison operator tool as well. So that is just running through a recap. And I now started talking about the collection type. That the collection type in Python, that their examples are list, tuple, dictionary, and set. That on a daily basis, you are likely going to encounter list, tuple, dictionary more often as geoscientists. And so that is why I am essentially talking about these ones. And then I create a variable called my gamma release. So this is a variable. Mind you, please kindly note on when you're looking at my screen, on the left-hand side, whatever is on the left-hand side like this is a variable, is a variable name. Then what you see in between, which is equal to symbol, is an assignment. So then what you see on the right side is the value or the variable itself, the value or the variable itself. So what that means is that variable name, assignment, and the value of the variable. Variable name, assignment, value of the variable. So essentially, we have been able to touch base with that. So let's look at how we can iterate through a collection, for an example. So this is a list. I mean, in Python, when you see square bracket like this, just note that it is a list. So in Python, when you see a square bracket, so this is for list. So so let's iterate through. I want to just show us how we can iterate through. So I can say for gr underscore value underscore value in my gamma ray list. So I can say print gr underscore value. So if I run this, you can see it is able to print each item that we have there. It is able to print 50.0, 30.0, and all that. So basically, what we've just done here is to iterate or look through a collection. List is an example of a collection. So I've listed it here. I said collection, example of collections are list, tuple, dictionaries, and set. So essentially, doing that, we'll be able to look through a list. So now, let's also look at tuple. Then we'll now apply some of the stuff that we've learned before in it. So let's say my gamma ray tuple. So tuple is usually denoted with a normal bracket. So we can say 20.7, 34.8, 9.3, 12.9, 6.7. So this one is supposed to be in. So in also note in Python, when you see a collection of items in a bracket, it is a tuple. So you can also look through a tuple. So essentially, looking through a tuple would mean so we can say gr underscore tuple in my primary tuple. You can say print gr underscore tuple. Then we can run this. So okay, so that we'll know the difference. Let me just comment out this other one. Let me just say pass. So pass is just, I'm just saying you should ignore any error that it may have beneath it. So you can see essentially we're able to print this. So, but they have different use case. You may be wondering, oh, why should I, when they perform basically the same thing, why should I use one over the other? I will touch base with that, but essentially it's because there are some times that we need to edit XYZ information from an existing collection. And there are some times we don't need to edit an information. So when you don't need to edit an information, most of the time you use tuple. I mean, if you want something to remain as it is, whenever you're manipulating it, you use tuple. But when you know that something may be changing within the values of the list or the collection, most of the time you either use a list or a dictionary. So let's just look at dictionary real quick, and then we'll bring it up together in terms of applying the control flow logic and the likes in this stuff. So let's just say my where underscore log underscore dictionary. So so essentially, I'm going to show us an example of a dictionary here. So to show us an example of a dictionary can hold multiple data type or various data type, but to limit it to what we are doing a bit, I would say gamma ray or GR. Then I would say GR is a list of let me just copy this. Then I would say the other log type that is common, let's just say caliper. Let me just copy this value, but I'll change the value a bit. So I'll change this one to 55. I'll change this one to 64. I'll change this one to 28. I'll change this one to 37. I'll change this one to 96. So, so for instance, I've just created a dictionary holding several word values. So essentially, I'm referring back to this again, because essentially when you start passing this value, when you start passing this this file, it will give you something like this. It will give you, let me put it side by side. It will give you something like this when you start, when you start passing it, it will give you something like this. So what it means is that dictionary have what is called key value. The key will be the log type. The value will be the readings. So for instance, let's say you carry out a geochemistry study and you have a certain kerogen type with their reading. You would study it in type of in format like this. So essentially, you have a key that is pointing to a value. A key that is pointing to a value. I'm repeating that again. A key that is pointing to a value. A key that is pointing to a value. Or what some people would say, like your address. When you want to look up an address, every address is denoted by certain information. So basically, that is just what that means. So so we can also look through this. Funny enough, we can also look through this, and to look through that, we can look through it. We can also pick the value based on that. Let me just, I'll just look through it real quick, and then so I'll just look through it, and then I'll show us an example of how to do that. Okay, before I show us how to look through it, I think I need to first show us that we can access them by their key. Okay, let me first show us that, and then so you can see that the compiler is smart enough. So if, for instance, if I run this now, it will print. You can see it went straight and fetched this value. Went straight and fetched that value. So where am I? Okay. So it went straight and fetched this value. And let's say, let me comment out this. Let me say pass. Okay. So you can say my well-log dictionary. You see, you can see it printed the one for GR value, the gamma ray value. So which means we can access each item by their we can access each item by their key. We can access the value by their key. So what we're basically doing is that we are saying my well log, and we are telling it that give me what is the value that has the key GR, and then it went straight to print this for us. When we said it should give us the dictionary with the key of caliper, it went straight and fetched the value. But we can also look through it actually. So let's just look through it real quick. So I would say key in our dictionary. So then we can say print. Let's first see what happened. So you can see. So let's try something. Oh, sorry, it's raising the value of my bad. So say we'll save the values. Indices must be an integer, not a string. Okay. Oh, sorry. I was accessing the wrong. Okay, so sorry. Yeah. But mind you, there's another way we can do that. I think I will explain why we had that error and the message of that error. Like there are ways we can do that. So let's say, for instance, another thing we can do is to say so there's an inbuilt method in Python that is called items. Let's say item. Let's see what I would say. I would then explain some difference and some similarities. So yeah. So basically what we've seen here is I said it should get me the items, and I'm saying for each item you can see how we printed it out here. So but it treated it as a tuple. Yeah, if you can recollect our tuple data type when it's printing it out, when it's printing out this item. So you can see it's saying item will be a tuple of string and list of float. So essentially, we've touched base with that. But however, for list of items, list always, or for most time, usually have an index of integer. Index means like the address or the location. So that was why when I was mistakenly iterating through this, yeah, it was telling me that it needs an. So for instance, if I say to explain that clearly, what I'm trying to say is that if I say what is in location 5, so let me say pass. So essentially, when I said my gamma ray list and I put square bracket and I put location 5 or 5, so it printed 23. So if we are to count this, so it starts from 0, 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. So if I want to get the first item, I would have just said 0, and then it printed me 6. I say 6, this one. So essentially, that is how to access an information from a list and dictionary, essentially. So now let's connect some of these things together. Let's look at how we can apply our control flows and the likes in things like this. How do we apply them? Let's look at, let's say we have a gamma ray list and we want to look through it and we want to We want to say how many items belong to a certain lithology type. So let's say um, lithology underscore types underscore font. So we want to say for lithology type that we found, we want to create a dictionary, but that is when we are looking through this gamma ray list. So what we want to do is that anywhere we find a certain value, we want to group it as for ER underscore V in this. So we want to say, remember I talked about the conditionals. So we want to say if our GR underscore V is less than 50, we want to say lithology type font, and we want to specify the key of sandstone, and we want to say ER underscore V. Sorry. Else if GR underscore V, underscore V is greater than 50, and GR underscore V is less than, let's say 75. Let's say 75. So we want to say lithology type font should be, let's just call it intercalation. I'm just using any name. So by the time we start doing the real analysis, we would be able to apply our geophysical knowledge, but this is just to give us a clue of how things work under the hood. Else, anything greater than 75, I want to say the lithology type font is shale. So now, so let's run this. Let's see what happens. So it's basically just picking one of the values, but I can make it append. Actually, I can make it append. I can make it append, but I mean this is just sufficient enough for now. I can make it append in that you have a collection of value, but this is just basically sufficient enough. You can see how it's able to group them. That we have sandstone, that the value that belongs to 23.9 is a sandstone. The one that has 56.9 is an intercalation. The one that has 80 is a share. So example, let me just say sandstone. Let me make that an empty list. Let me say shape. Let me make that an empty list. Let me say intercalation. Let me make that an empty list. So what I'll do is I would say sandstone dot append gr underscore v when in append tr_v, I want to set this to be sandstone, then I can say intercalation dot append. Append means you are adding an item. Then I want to say it is intercalation. Then I want to say shell dot append. Let's go. So then we can say that is shell. So you can see essentially that we've been able to group our lithology. So essentially, by the time we start manipulating this data set that you're seeing here, this is an example of a typical workflow that we'll be achieving. Yeah, what we're essentially doing now is an example of how, when we're manipulating data, what is likely going to happen when we start reading an item as a list or a collection or a dictionary of an item, and we're categorizing our lithology based on whatever we found at every depth or every rows and all that. So that is just basically about it on collection. So I will go through this again. I mean, it can be more in-depth than this, but you know, this is a workshop, there is time limit, and we just have to find a way to maximize and touch a couple of stuff so that when you're on your own, it can ignite your curiosity and all that. So basically, we've looked at several collection types. We've looked at list, tuple, dictionary. We didn't look at set now. I will not be able to touch with that because I still need to touch concept like function or module or subroutine and the like. So that is why I can't touch set, so that we don't dwell too much time and not being able to maximize some of the other things that we're supposed to touch. So let's look at example of, okay, let me just explain some of these ones again. So we add this variable here called my gamma ray list, and it contains list of various gamma ray value. So now remember that here we've talked about your if statement, your conditionals. So what I did is, and we also talked about looping. So what I did is I combined both looping. I combined the collection data type, which is like a dictionary or a list. I combined the various collection data type, the dictionary, the list, and I also combined the if statement. And I'm able to generate a typical geophysical result from it. I mean, this is a text-based. We'll still be able to do visualization and all that with it, but I'm just prepping our mind, giving us a foundation of how things go on under the hood in some of these solutions. So with that, I now look through each of the gamma ray value, and I'm saying that wherever the gamma ray is less than 50, I'm adding it to a list that I already created here, which is a variable called sandstone. Then when I'm adding it, I'm saying that after adding it, I want to assign it to a key called sandstone of a lithology type font dictionary. A lithology type font dictionary, you can see it's a dictionary, it's an empty dictionary. So I created a variable called lithology type font. I set it to an empty dictionary. And then I also created a variable called sandstone. I set it to an empty list because I want to start adding an item. Wherever I find whatever matches sandstone, I want to be adding it there, or to keep track of it, to use it as a reference point. Then I said, I created another variable called shell, is an empty list. And then I created another variable called intercalation. I make it an empty list. So I said, for every GR value that is in gamma ray list, whenever you find a GR value that is less than 50, kindly append it to the sandstone list. After you have appended to sandstone list, assign it to the dictionary, but give it a key called sandstone so that I will know that it belongs to sandstone. Then I said if or else if the GR value is greater than 50 and it is less than 75, I'm saying append it to the intercalation list. Then when you append it to the intercalation list, assign it to the lithology type font, but give it a key or an address value of intercalation. So, and I said, else, if it is greater than 50 and it is greater than 75, it should be a shade. I mean, this is just generic. I mean, there are rules that guide some of this stuff, but it's just to set the foundation for us and help us understand how some of this stuff happen under the rule. So, as I said, where you find any value that is greater than 50 and 75, append it to the shade. So, and then print it out, and you can see essentially it has grouped them. So essentially we have shale having just two value, 50, 80, sandstone, this and this and that, and all those stuff. So, I mean, it's just that way. So basically we've been able to create a collection like this. So that is how people group lithology and create or generate crossplot. In future, we'll be able to use some of these stuff to generate crossplot using several Python libraries. So let me also move to the next phase of this, and that is where I want to talk about functions, because you need functions and you need to know how to use function and some basic stuff like that. Is because by tomorrow when we start importing some libraries, you'll be wondering how are they able to perform that? I mean, where did that come from? It is because somebody wrote a function or a module that we can use. And in Python, how do we define a function? We can say we use the keyword def. So where's my function? After creating the keyword def, we give it a name. So let's say the name is evaluate underscore well underscore logs. So then I say, I'll tell it that it's going to take log underscore type is equals to this. So I'm saying the log type should expect a list of items. So basically, what I want to do is I want to move everything that we have here. I want to copy it. This is to show us how we can convert our what we've written into like a library or like something that we can reuse. Functions allow us to generate things that we can reuse based on the functionality or based on the tasks that they perform. So, for instance, this would be that. So let's say let's obtain the variable bit so that we don't get confused. I'm just trying to change the variable name a bit so that we don't get confused. I mean, we are almost done with this. Then I'm telling the function to return. So now, basically what we have done is we have created a function. I will put an explanation here. So we created a function that will return various lithology as a dictionary associating each lithology to their respective values. So, so now, you know, we wrote all this, right? So I want to do something. I want to comment out this. We want to use our function now. We created a function. We want to use it. So let's try and use it. Let's try and use it. So we want to use the function now. Before we use it, so let me first run it. So I've run the function now. Then let me run it. Let's see the output. You can see it generated the same thing for us. So basically, we've been able to group it based on the functionality. Based on the functionality that we want to, based on the tasks that we want to perform, we've been able to group it. And when we run it, we are able to generate a result the same way. So basically, you start seeing an application of things like this function when we start doing some visualization. So you see also have a function that we can reuse, and that way we can make a whole lot of good use of some of these things, and that allows us to perform several stuff. Like if you recollect, I mentioned libraries like pandas and like, so that is why you're able to use. When we start using some of this library, you'll be wondering, how are you able to use them? It's because somebody wrote something like this and make it accessible to us. So we just need to pass our value and it generates a result for us. Mind you, there are some edge cases that I didn't handle yet. I didn't check if it is an empty list or not and all that. So normally I'm supposed to also check if it's an empty list or not. So, but I mean, that is just to give us an example of how a function looks like. So basically, function is just a way to group your code or your script in terms of how they perform by giving it a name based on the functionality or the task that it performs. And that allows you to do a whole lot of manipulation, data manipulation, and the like. Though I would also like to talk about the object data type like classes and all that, but there is how far we can go with that, and because I know that some of these things can be very overwhelming when starting out. So I just want to do one more thing for today, and then I'll take questions, and then in our next class we'll start doing some visualization by passing some of these values and reading it into and using libraries like pandas and the likes of it. So let me show us something. There's a keyword in Python called import. So what I want to do is the same thing. I want to move this into a separate file. I'm moving this into a separate file. I want to show us how people create libraries that we use. So I'll just say import. Yes. Okay. So okay, it's here. Okay. Okay, so it's because they are in the same. Okay. Didn't work as expected, but so it's able to read it because they belong to the same. So let me just say import. Okay. So now let me run this. Okay, good. So basically, this is an example of when we start using library in our next class. You start understanding this, but I want to explain it a bit. So, for instance, that code was here before. I've moved it into a separate file. Let me zoom this in as well. So we can see that I've moved the code into a separate file, and after moving it into a separate file, I am able to access it here. How am I able to access it here? I said from DS. So I'm saying from the file called ds.py or ds that it should import star. Import star means it should import everything. It means it should import everything. So we can import a simple We can import a function, we can import a whole lot of things. But I'm saying you should import everything so that everything now becomes like as if they're in the same. It's just like taking a visitor into your house. So let's say you have a friend that your friend is able to do certain tasks, and you are inviting your friend over to your house to be able to help you do some house calls. So what that means is that you are importing your friend into your house, and you are saying that your house should be accessible to your friend. Your friend should have access to everything in your house so that your friend can help you in terms of helping you to clean, helping you to do one or two things. So basically that is what is happening here. So I'm saying from DS import star, and then from there I'm able to call the function. If you look at this one, we had the function in a separate file, and we are able to call it here, and it didn't give us any error, and it ran successfully. So essentially, that is an example of how we are going to use some libraries, because we'll be using some libraries that is called pandas. For instance, I can say, for instance, seed. You can say, I say from pandas, I can say import PD. If I run this now, it's saying cannot import this and that. But if I said import pandas as PD, if I run this, it will run. So essentially, we'll start using this library called pandas and the likes in our next session. But we just did example of what this pandas is a module. You can see it is also calling our own DS Python file as a module. And you can see, let me zoom it in a bit so that you can also see it more. So when I put my mouse on this, you can see it is calling it a module DS. When I put my mouse on this is a library that is existing already. I mean, I added because I downloaded Anaconda. You can see it is also reading it as a module. It's calling it a module called pandas, and it's calling what we also wrote here as also a module as well. So we'll start using these pandas to start solving some data-related questions, like problem, like importing this and kind of visualization. So our next class will be using some of these libraries. We have libraries like NumPy. We have libraries like NumPy. So essentially, we'll be using libraries like another library that we'll be using much later in our next class is NumPy. Start using NumPy. That's NP. We'll use matplotlib. We'll use this one too, matplotlib. We'll use all these ones. We'll use all these ones essentially, and so we'll use okay. Let me explain something here. Depending where we'll start working on it. I said import pandas as PD. So I'm basically just giving it an alias or an alias, like people will call it. It's an alias. So I'm saying pandas should be anytime I use the word PD. So anytime I say PD and I say dot, it should give me, you can see all the functions that are available in the pandas library or module becomes accessible to me. You can see like read CSV, read Excel, read clipboard, pivot table, read JSON, read HTML, read Parquet, read SQL table, like a whole lot of stuff like that. So basically, it becomes accessible to us. So the same thing with NumPy. So in our next class or in our next session of workshop, we'll start using some of this library to build an example of a geophysical data model. So example of, we'll start generating stuff. In our next class, we'll be able to generate an example of something like this, using that library or module like that to generate something like this. We'll create a basic workflow and we'll generate something like that. So today is just to set a foundation in terms of some of the technical tools that we'll use, because when you start seeing them, that we'll use them in our next session of workshop, you don't look confused or run out of idea of how did this achieve. So to recap, essentially, we've been able to onboard us on why you should care when it comes to data science and machine learning, because you're able to build your own tools and your own data manipulation libraries. You're able to also augment your data, like some of the stuff that we do today, we're able to augment data and manipulate the data and extract common feature. And then are there use case? I said yes, there are use case. There are use case in geochemistry, there are use case in petrophysics, there are use case in data prediction and image recognition and all that. And I said, are there tools that I need to master? Yes, you should, but you should only start small, bit by bit. And we looked at example of Python today, and we'll be able to use some of this library like Pandas, Matplotlib, NumPy, especially some of these three libraries. We'll be able to use them in our next class to generate a geophysical output. And example of our workflow will be, in our next session, will be to import the data, we process the data, we are able to visualize the data and generate any model that wants to trace from it. And then, like we looked at Python today, to recap, we looked at some of the important data types that you should know as a geoscientist, like your float, the ones that you encounter the most, the float, string, and numbers or integers, your operators like your equal to or double equal to, your control flow, which are basically your if statements and all that. And then we looked at looping through some of these collection types. Look at the Python collection types like this, like dictionary and tuple. And exception handling means handling some of our errors. So dealing with files and all that, yeah, we'll deal with files, but when we start dealing with files, we'll be able to use some of this library. So that ends today's session of the workshop for me, but I'm open to questions and anything that the viewers may want to ask or request of me.
Thank you very much, sir, for this informative session. And we have questions with us. Hello, sir, am I audible?
Yes, you are audible. I can hear you loud and clear.
Okay, sir. So the first question is, are you using Python codes in Visual Studio? Why not in Python program?
Okay, so essentially, Python is a programming language, and Visual Studio Code is like an IDE or a tool for you to write the Python code. I mean, in an ideal world, if you are to write a code, you probably write it on pen and paper, using pen and paper. But tools like IDE, like this Visual Studio Code, allows us to write our program and visualize it in real time. So I'm able to write it here because I want you to be able to see the visualization. But essentially, the content of this editor or Visual Studio Code, some people will call it an editor or IDE, Integrated Development Environment, or some people call it code editor, is for you to see the content of the program. So the program that I'm writing is written in Python, but it is written, but I'm showing you the display. I'm writing it inside an editor or an IDE.
Okay, thank you, sir. So the second question is from Hakim Alam. Can we use machine learning skills as a predictive tool for mineral exploration? If yes, then how?
Okay, yes, you are right. It's a good question. So you can use machine learning for predictive stuff in mineral exploration. In mineral exploration, what are the key things that you look out for? Those are the questions you need to ask. And some of the key things that you look out for in mineral exploration are the various composition or the mineral composition of this rock type and all that. And when you're able to know all these questions, you can put them into machine learning and say, okay, for instance, let's say in 1950, there was a mining at, let's say somewhere in Hyderabad that mined for, let's say, coal, or that mined for, let's say, timberlite, or any of these minerals that you have out there, or shale, or kaolin and the like. So you can carry some of these results, feed it into a machine learning. Machine learning looks at this image and recognize them. And then when you feed it with a new one, it's able to predict and say, okay, based on what I've seen before, or based on the previous record that you feed me with, I can accurately or near accurately predict that this is also a kaolin. So, for instance, I can get an image. If I'm trying to identify several mineral types, I can get an image of some of this mineral type. I feed it into image recognitions and all that. And then when I feed it into image recognition, I train the image recognition model over and over again. I train it over and over again with several data types. So when I train it over and over again with several data types, it's able to recognize that, okay, this is a certain mineral type. Then if I feed it with another unknown mineral type, it's able to tell me whether it is yes or no. Example, there was a project I worked with for Interica. We used some of this feature of the image recognition part. We wanted to be able to recognize based on, without the solution knowing if this is a well log or not. We want to throw an image to it and it's able to predict if it's a well log or not. So I was able to build the model and all that. And from there, when you run it, it's able to predict what is a well log because I have trained it over and over again with several well log. So when it sees a well log, it knows that, okay, this is a gamma ray log. It knows that this is it's able to recognize. So in the same way, mineral exploration, when you are exploring for minerals, you are essentially, the key concept of mineral exploration is to identify minerals. And when you identify minerals, how commercially viable are they? You can do all these things in Python and machine learning, because when you are able to recognize the mineral, the next thing is to estimate. You want to estimate things like tonnage and the likes, and you want to see if you are to mine it, how much are you going to make of it, or how long can you mine it? So things like this, you can do it in machine learning and in Python. Sure.
Okay, thank you, sir. So as there are many participants who are new to the Python language, so there is a question that where to start learning Python if we are beginners, and how to imply it in geosciences.
Okay, so at the end of the, it's a good question. At the end of the workshop, I'm supposed to also share some online resources where you can go and learn Python. Essentially, it depends on what works best for you. I mean, you might be the type that likes to, I would say, if I were you, I would pay for knowledge. Pay for knowledge in the sense that there are several online stuff like Pluralsight, Udemy, and the likes, where you can learn Python from more in depth than this. But as applied to geoscience, I think I will come up with a list of resources that can help you on that. I will come up with a list of resources on that, because some of the online learning solution for Python are tending towards the general Python as applicable in other fields and not drilling down to geoscience. But mind you, it's also set the background for what you learn in geoscience. So for geoscience, I would look out for some of these. I will create a list of some of these sites that you need to follow, and people that you need to follow online and all that, where you will learn more from or through them in terms of this. So there are resources online like Udemy, like Pluralsight, which other one, like LinkedIn Learning, like YouTube. There are many of them where you can learn some basic Python from. But you know, for instance, today we were showing how you can categorize lithology into different lithology. So they may not show you things like this, because this is, I mean, using some keywords in geoscience, but you have a grasp, you have an understanding of how Python is applicable and how to apply Python. But the key thing you also need to do is not just learning and going to bed. It means learning and you keep practicing, keep trying to solve a problem with it, no matter how basic or how small it is. That way you're able to expand your skill set, and that way you're able to grow in that as well.
Okay, thank you, sir. So next question is Studio, Anaconda, Jupyter Notebook. Which one is better to use for DS and ML?
Okay, yeah, a very good question. I like the curiosity. Okay, I would say for me, I would say if you really want to master a lot of things, you download Anaconda first, because Anaconda comes out of box with a lot of the library. After that, I say you should use VS Code to do a lot of your writing program or PyCharm. But VS Code is very robust when it comes to that, because that will help you build what is called a muscle memory. Because as you're typing some of this stuff, it will stick in your brain and all that. And Jupyter Notebook is just like where you prototype your idea, or a writing ground where you know, if you think of a journalist, when they want to come up with a story, they have a notepad where they just write a draft of their story before they put it up together. So think of Jupyter Notebook like where you flesh out your ideas and all that. But when you want to solve some of this problem and all that, the key thing you need to have is you have to have Jupyter Anaconda VS Code. Anaconda would come with some of the key libraries that you may need. And VS Code will allow you to do some of the debugging and handling of some of the errors and all the stuff. And another thing you want to have is just have a fairly good machine that can run without crashing. I mean, not too big, but I mean something fair. Although there are online cloud storage that allows you not use your machine that you can use online, like Google Colab, Azure Notebook, Data Law, and the likes. But I mean, sometimes having it on a local machine helps you have that willingness to always practice.
Thank you, sir. The next question is, to do quantitative analysis using geospatial data, what you will suggest?
Okay, good. I'll suggest Python, and there are a lot of Python library that does geospatial spatial stuff. I think what I would also do is in the next session, I will come up with I would like to know some of our audience, their key sector. So I'll come up with some of the list of Python libraries in individual sectors which they operate in so that they can learn those libraries and master them. There are a lot of Python library for GIS that can draw your GIS map, overlay, like layers and all the stuff that you have in GIS. And there are also tools that can plot mineral heat map, or if you are doing geophysical investigation in subsurface borehole, you can also do some of this plotting and all that. There are libraries that does that. So if I have an idea of at least some of our participants, the industry or the subsectors of geoscience in which they operate, I can come up with a list of libraries that they need to master that they can apply in these areas.
Thank you, sir. Sir, there is question regarding that. You told about the industries that the skill we should learn to be a competent geologist in a private sector.
Okay, to be a competent geologist in the private sector, I would say, number one, your primary geology knowledge is important. I mean, what are faults, what are seal, what are faults, and all those stuff. You should know them. Obviously, you should have them at the back of your hand. Then, to set yourself apart in this current age and time, you would have to have an understanding of data science and machine learning, because that way you are able to solve complex problems. Or solve problem as it should based on that. I mean, you'll be able to apply yourself and have some sort of critical reasoning and understand why some of these softwares that we use in the industry, like the Oasis Montage and like how they operate under hood, and you're able to build a predictive model that you can reuse over and over again. So to be competent in geology in the industry, have a strong knowledge of your geology, improve your background of geology if it means reading wide, if it means brushing up some of the stuff that you may have forgotten before. Then add the technical skills of having knowledge like Python, data science, and machine learning in it. And when you hook that up together, you are going to stand out. You are going to stand out. You are going to be able to deliver value. In fact, you can also set up your own company. You can set up geoscience analytical company where you help organization mine information out of their data set and you help them solve complex problems. Next question.
Thank you, sir. Sir, I surely confirm that if you are having a geological knowledge but not Python, then with these 2 days workshop, surely they will have that knowledge also. So next question is from Darius. What bare minimum codes or functions are needed to start with Python?
Okay. So, well, the knowledge that you are getting today is applicable in any part of geology first, and geophysics or any part of geoscience that you want to practice. Now, to start, the minimum requirement that you need is what I say is the minimum requirement that you need is the willingness, the grit, the consciousness that you want to get better, and that's the minimum requirement first. Because if you don't have the willingness and grit to get better at some of these stuff, you end up winding around and not having the motivation to drive through. The other thing that you need to get is a good laptop. I mean, not essentially too expensive. Good laptop, a stable internet, because by the time you start buying some of these courses online, you need to continue to learn and all that. A good laptop, a good internet, and your curiosity. That is all. And you'll be amazed at how far you will go. I can bet you'll be amazed at how far you will go. I've seen people that I've mentored that they started from nowhere and now they are very good at machine learning. They build a lot of models. They've consulted for a lot of companies outside of their domain and all that. They all started with having curiosity to solve a problem, having the grit to stay consistent, even when sometimes it can be frustrating. You know, what I'm saying it can be frustrating sometimes is that sometimes you are trying to solve a problem and you're not getting it. And you're confused, you don't know who to talk to. But having that passion, that grit will keep you motivated and keep you pushing at all times. That is basically all you need. And also be willing to reach out to people within the community, within the industry, where you feel you may need mentorship. Mentorship is also important because if you have mentorship, you have people that you can, I mean, your mentors may have passed through some of this stuff before they just tell you that, oh, why don't you use this? For example, there is someone that was doing a master's, and she trained a model, and our model was not giving her the right accuracy that she wanted. She talked to me, she sent me a message, and I just advised her. I didn't essentially solve the problem for her, do the work for her, but I just gave her an idea of, okay, do this, do that, and she got it right. Then the next time she reached out to me again that, oh, she's trying to do this and that, she couldn't get a certain visualization. And I told her, okay, and I just sent her the link of a library to use. And she did that, and she's able to forge ahead with her master's in Imperial College. So while you are learning, have that curiosity yourself, but also try as much as well to reach out to people, be it people that are already in that area or people that are like you that are coming up in that area. You need the mix of both. You need the mix of people that are learning and the mix of people that are experienced or skilled in that area. That way you're able to build up yourself and have the dedicated strength to forge ahead.
Thank you, sir. The next question is from Abdul Ali. He just got confused with what IDE he should install to use these Python libraries more for geospatial data.
Okay, like I've said, the two things that you need to install essentially that are very important now that you should install is install Anaconda first, because Anaconda comes with a lot of libraries. So let me show you something. I'm going to show something. I'm coming. I'm trying to load up my Anaconda. I'll just show you some of the libraries that are already inbuilt in Anaconda. Then I'll be able to talk about that. So it's still coming up. Just give me a brief moment. I'm waiting for it to come up. Just hold on for me. So once it comes up, okay. So let me. So I would. So now, for instance, after installing Anaconda, you can see some of the stuff that are here, but don't focus your attention on this one. If I click on the environment, you can see how many libraries that are here. So let's search for something that is geo. Let me search for something, the one that is not installed. So you can see GeoAlchemy, GeoPandas, GeoOS, GeoView, GeoViewCores. If you can see my screen, I'm not sure if I can zoom this one, but if you can see my screen, you can see how many libraries that has the word geo in them. So these are essentially libraries that's what Anaconda helps you with. Anaconda helps you organize or search for some of these libraries that you may need easily and all that. Then the other thing that you need to do is to have Visual Studio Code. Mind you, once you install Anaconda would come with Jupyter Notebook. this notebook for you. And then it will also install this Jupyter Lab. But essentially, I would advise you also download Visual Studio Code. Visual Studio Code allows you to write program like this. And for instance, this is a Jupyter notebook. I'm using it inside the Visual Studio Code. This is a Python like file .py. Any file that you see that has .py extension, a py extension is a Python file. So it allows you to be able to do all that. So I would say focus on having Anaconda and Visual Studio Code to start with. You'll be able to use Anaconda to run all your installation when you want to install a library and all this other stuff. Next question.
Thank you very much, sir. With these questions, we have came to the question answer end.
Okay.
Sir, there was a query that when you will take the second class, as you were saying that you will keep it after some days. So
okay. The thing is, I am supposed to attend a church in the morning tomorrow because I'm in the morning here. And if we are to have it tomorrow, it will clash with my church service, and I also need to present in church. So that is why I'm saying if we can put it in the middle of the week or by this time next weekend. So either in the middle of the week, which can be either Thursday or a Saturday like this.
Sir, can you suggest some day in the middle of the week, or can you go with Monday?
Monday will be busy for me. I always have a lot of meetings here on Monday. Monday is always meeting from morning till evening. And then Tuesday, I'm also preparing some sort of report for the Wednesday meeting. So I think Thursday is usually the free day for me within the week. Thursday, Friday, and Saturday. So if our participant can be kind enough to let us pick a date between Thursday, Friday, and Saturday, then that would be fine with me.
Then, sir, we can go with next Saturday only.
Okay, great.
Everyone will be free that Saturday.
Yes, sure.
Okay, so thank you, everyone. So we will meet on next Saturday for second day workshop. Up to then, stay safe, and we will take your questions that day also. If you have question for today's session, then you can ask that day also. We will take your questions from YouTube chat or from WhatsApp group also. Thank you, sir. Sir, anything you want to suggest to participants?
I want to suggest participants that they should motivate themselves. They should have that curiosity. Whether you're a professor, you're a lecturer, you are a student, you are working class professionals and all that. There's so much you can take away from this. I mean, this is just, we are scratching the surface in this workshop, but there's so much you can learn on your own with that motivation, with that passion and all that. You can do a whole lot of stuff. You can build your own company. You can build your own expertise around this. You can use it to equip your studying if you're a student. As a lecturer, you can use it to modify your syllabus in terms of how you teach some of your students with the skill set that the industry may require of them and all that. So there's so much you can take away from this. I would encourage the participants that they should stay safe, stay motivated, and I hope to see them all taking this as a launch pad to practicing more or to doing something greater than what they've seen here today.
Okay, thank you very much, sir, for today's session.
Thank you.
We will meet you all participants in next day on Saturday after a week at the same time. Thank you very much, sir.
Thank you.
sir.